8.2 The Prophetic Property of Probability by Matthew Seidman. In this video, we will learn about what probability is, the origins of probability, how to calculate probability, and why probability is so important. What is probability? Probability is defined as the likelihood of a certain event happening. This likelihood often serves as the foundation for what we think of as common sense. For example, it is common sense to wear a coat tomorrow in the fall because it is likely that the temperature outside will be cold. Origins of probability. Well-known French nobleman and notorious gambler Antoine Gombaud wondered why he would often lose betting that a double six would occur within 24 rolls of the dice. Famous French mathematicians Blaise Pascal and Pierre de Fermat discovered in 1654 that Gombaud would often lose because the odds of him winning were less than 50%. We will learn more about how to calculate probability in the next few slides, but for now, Pascal and Fermat used the formula 1 minus 35 over 36, which is the odds of not rolling a double six, raised to the 24th power because of the 24 rolls that would be thrown, and they found that there was only a 49.1% chance of rolling a double six in 24 rolls. So in other words, Gombaud was more likely to lose than to win. This answer by Pascal and Fermat led to the creation of the first modern principles of probability, and we continue to use these principles to this very day. How do you calculate probability? There are two main formulas used for finding the probability of an event occurring, and we will be using the variable e to represent any specific event. The first formula that can be used to find the probability of event E occurring is by dividing the number of different outcomes in E by the total number of equally likely outcomes. The second formula that can be used to find the probability of event E occurring is by doing 1 minus the probability that event E will not occur. These two formulas will result in a fraction between 0 and 1 to be calculated. The closer the fraction is to 1 means the more likely that this event will happen. The closer the fraction is to 0 means the less likely that this event will happen. Two other concepts closely related to probability are relative frequency and the law of large numbers. The formula used to find the relative frequency of an outcome is by dividing the number of times the outcome occurred by the total number of times the experiment was repeated. Relative frequency is used to keep track of the number of times a specific outcome occurs. For example, if we rolled a dice 100 times and rolled the number 2 a total of 12 times, then the relative frequency of rolling a 2 in this experiment was 0.12, or 12 divided by 100. The law of large numbers states that if an experiment is repeated a large number of times, then the relative frequency of a particular outcome will tend to be close to the actual probability of that outcome. For example, if we rolled the dice 1,000 times instead of 100, then we would most likely roll a 2 closer to the actual probability of rolling a 2, which is 1/6 of the time. Now let's solve some probability questions using what we've learned. This problem comes from Mindscape 14. Marbles marked 1 through 10 have been placed into a jar. The probability of pulling a marble that has a factor of 3. We know that there are 3 marbles in this jar that have a factor of 3, 6, and 9. So that means that the probability is 3 out of 10 or 0.3. Is a prime number. We know that there are 4 marbles in this jar that are a prime number, 2, 3, 5, and 7. So the probability is 4 out of 10 or 0.4. Is an even number. We know that there are 5 even marbles in this jar, 2, 4, 6, 8, and 10. So the probability is 5 out of 10 or 0.5. And finally, is evenly divisible by 13. There are no marbles in this jar that are evenly divisible by 13, so the probability is 0. The formula we used to find the probability of each event occurring in this question was done by dividing the number of different outcomes for that event divided by the total number of equally likely outcomes. Let's solve another problem. This problem comes from Mindscape 18. A roulette wheel has 36 spaces marked from 1 to 36, half of which are marked red and half black. In addition, there are 2 green spaces marked 0 and 00. What is the probability of landing on 13? To find the probability of landing on 13, we can do 1 minus the odds of not landing on 13, which is 37 out of 38. To find the probability of landing on 13 to be 1 out of 38 or 0.026. We can also do the same thing to find the probability of landing on red. We can do 1 minus the odds of not landing on red, which is 20 out of 38. To find the probability of landing on red is 18 out of 38 or 0.474. The formula we used to find the probability of each event was 1 minus the probability that that event would not happen. Let's solve one last problem, and this is called the Yahtzee pair question. This question is asking, what is the probability of rolling 5 dice and getting at least one matched pair? For this problem, we'll be using the formula of 1 minus the probability of seeing 5 different numbers when rolling 5 dice. In order to do this, we need to find the total amount of possibilities of not rolling a matched pair out of 5 dice and dividing this number by the total amount of possibilities. So let's see. The first die can show any number 1 from 6, so there are 6 acceptable possibilities. The second die can show any number except for the number of the first die, so there are 5 acceptable possibilities. The third die must avoid the numbers of the first and second die, so there are only 4 acceptable possibilities. This pattern continues for all 5 dice, and we soon realize that there are 6 times 5 times 4 times 3 times 2 amount of outcomes for not having at least one matched pair out of 6 to the 5th power total outcomes. So now we can do the formula of 1 minus the probability of seeing 5 different numbers and then dividing this by the total amount of outcomes to find that there is about a 90% chance of rolling 5 dice and getting at least one matched pair. So why am I teaching about probability? What is the importance of probability? Probability is a major influencer on our daily decisions and actions. Common questions involving likelihoods, risks, and chances are being answered by us all the time. What type of clothing should I wear tomorrow? Do I buy groceries now, or wait until I expect the store to be less crowded? Should I take the highway home or the back roads? Such questions like these are being answered all the time, and they all involve probability. We live in a world full of uncertainty, and it's impossible for us to predict the future with absolute certainty. Probability is simply the key tool that allows us to predict future events with the highest odds of being correct, and it will forever be an important part of our lives, no matter if we know so or not. So what do we learn after watching this video? We first learned what is probability. Probability is the likelihood that a certain event happens. We then learned about who created the principles of probability. And this was the famous French mathematicians Blaise Pascal and Pierre de Fermat in 1654. Next, we learned about how you calculate probability, and this is shown by the formulas seen here. Finally, we learned about why probability is so important. And this is because we use probability every day, and it is used to calculate the most accurate predictions of the uncertain future. This is the end of the video, and this is my works cited for the information used in the video. And this is my works cited for the images that were used throughout the video. I would like to thank everybody for watching, and hopefully you enjoyed and learned something. Thank you.